Hello, I am Nurul PMP CPHI and Untitled Certified, and welcome to my presentation on PMBOK Guide 7th edition. In this part, we are going to explore planning performance domain. It is one of the 8 performance domains. So let's start. Planning performance domain. First, we will explore some definitions. The following definitions are relevant to the planning performance domain. Estimate: a quantitative assessment of the likely amount or outcome of variable such as project cost, resources, effort, or duration. Accuracy: within the quality management system, accuracy is an assessment of correctness. Precision: within the quality management system, precision is an assessment of exactness. Crashing: a method used to shorten the schedule duration for the least incremental cost by adding resources. And fast tracking: a schedule compression method in which activities are phases normally done in sequence are performed in parallel for at least a portion of their duration. Budget: the approved estimate for the project or any work breakdown structure, WPS component, or any schedule activity. So let's see planning performance domain. The planning performance domain addresses activities and functions associated with the initial, ongoing, and evolving organization and coordination necessary for delivering project deliverables and outcomes. Effective execution of this performance domain results in the following desired outcomes: the project progress in an organized, coordinated, and deliberate manner. There is a holistic approach to delivering the project outcomes. Evolving information is elaborated to produce the deliverables and outcomes for which the project was undertaken. Time spent planning is appropriate for the situation. Planning information is sufficient to manage stakeholder expectation. There is a process for the adoption of plans throughout the project based on emerging and changing needs or conditions. So we'll explore planning overview, planning variables, project team composition and structure, communication, physical resources, procurement, changes, matrix, alignment, interaction with other performance domains, and checking results. So let's explore one by one. First we'll explore planning overview. The purpose of the planning is to proactively develop an approach to create the project deliverables. The project deliverables drive the outcomes the project was undertaken to achieve. High-level planning may begin prior to project authorization. The project team progressively elaborates initial project documents such as vision statement, project charter, business case, or similar documents to identify or define a coordinated path to achieve the desired outcomes. The amount of time spent planning, both upfront and throughout the project, should be determined by the circumstances. It is inefficient to spend more time planning than is needed. Therefore, the information gained from planning should be sufficient to move forward in an appropriate manner, but not more detailed than necessary. Project teams use planning artifacts to confirm stakeholder expectation and provide stakeholders with the information they need to make decisions, take action, and maintain alignment between project and stakeholders. It is becoming more common for initial planning to consider social and environmental impacts in addition to the financial impact, sometimes referred to as the triple bottom line. This may take the form of product life cycle assessment, which evaluates the potential environmental impacts of a product, process, or system. The product life cycle assessment informs the design of products and processes. It considers the impacts of materials and processes with regard to sustainability, toxicity, and the environment. Now see planning variables. Because each project is unique, the amount, timing and frequency of planning varies. Variables that influence how project planning is conducted include but are not limited to development approach, project deliverables, organizational requirements, market condition, and legal or regulatory restriction. So let's see. First, development approach. The development approach can influence how much, and when planning is conducted. Examples include a specific phase for planning or organizing early in the life cycle. In this situation, much of the planning is performed upfront. The initial plans are progressively elaborated with more details throughout the project, but there is little change to the original scope. An approach with high-level planning upfront, followed by a design phase where prototyping is used. After the project team and stakeholders agree to the design, the project team complete more detailed planning. Adaptive approaches, where the project team conducts iteration, sub-planning occurs upfront to establish release plans, and further planning occurs at the beginning of each iteration. Project deliverables. Often the project deliverables necessitate planning in a specific way. Construction projects require significant upfront planning to account for design, approvals, materials purchasing, logistics, and delivery. Product development or high technology projects may use continuous and adaptive planning to allow for evolution, changes based on stakeholder feedback and technological advances. Organizational requirements. Organizational governance policies, procedures, processes, and culture may require project managers to produce specific planning artifacts. Market condition. Product development project can take place in high competitive environment. In this situation, project teams can undertake a minimum amount of upfront planning as the emphasis is on speed to the market. The cost of delay that extensive planning entails exceeds the risk of potential rework. Legal or regulatory restriction. Regulatory agencies or statutes may require specific planning documents before granting an authorization to proceed or to secure approval to release the project deliverables into the market. Now see delivery. Planning begins with understanding the business case, stakeholder requirements, and the project and product scope. Product scope is the features and functions that characterize a product, service, or result. Project scope is the work performed to deliver a product, service, or result with the specified features and functions. Predictive planning approaches start with the high-level project deliverables upfront and decompose them into more detail. This approach can employ a scope statement and or work breakdown structure WBS to decompose the scope into lower level of details. Projects that use iterative or incremental approaches can have high-level themes or epics that are decomposed into features, which are then further decomposed into user stories and other backlog items. Work that is unique, significant, risky, or novel can be prioritized to reduce the uncertainty associated with the project scope at the start of the project before significant investment has taken place. Project teams plan routine work based on the concept of last responsible moment. This approach differs a decision to allow the project team to consider multiple options until the cost of further delay would exceed the benefit. It reduces waste by not expending time in developing plans for work that may change or may not be needed. Now the estimating. Planning entails developing estimate for work effort, duration, cost, people and physical resources. Estimates are a quantitative assessment of the likely amount or outcome of variables such as project cost, resources, effort, or duration. As the project evolves, the estimate can change based on current information and circumstances. The project's phase in the life cycle impacts four aspects associated with the estimating: range, accuracy, precision, and confidence. Let's see range. Estimates tend to have a broad range at the start of the project when there is not much information about the project and product scope, stakeholders, requirements, risk and other information. Figure 2.14 shows a range of -25 to +75% at the start of exploring a project opportunity. Projects that are well along in their life cycle may have an estimating range of -5 to +10%. Okay, this diagram shows about time and range. Now see accuracy. Accuracy refers to the correctness of an estimate. Accuracy is linked to range in that the lower the accuracy, the larger the potential range of values. An estimate at the start of the project will have less accuracy than one that is developed halfway through the project. Precision. Precision is different from accuracy. See figure 2.15. Precision refers to the degree of exactness associated with the estimate. For example, an estimate of 2 days is more precise than sometime this week. The precision of estimates should be compatible with the desired accuracy. Now see confidence. Confidence increases with experience. Experience working on a previous similar project can help with the level of confidence required for new and evolving technology components. The confidence in estimate is expected to be low. There are different ways of presenting and or adjusting estimates. Deterministic and probabilistic estimating, absolute and relative estimating, flow-based estimating, and adjusting estimates for uncertainty. So let's see one by one. First we'll see deterministic probabilistic estimating. Deterministic estimate, also known as point estimate, present a single number or amount such as 36 months. Probabilistic estimates include a range of estimates along with associated probabilities within the range. They can be developed manually by A. Developing a weighted average based on multiple likely outcomes, or B. Running a simulation to develop probability analysis of particular outcome, usually in terms of cost or schedule. Probabilistic estimates derived from a computer simulation has three associated factors. Number one, a point estimate with range such as 36 months plus 3 months minus 1 month. A statement of confidence such as 95% confidence level. Number third, a probability distribution describing the dispersion of the data within and around the given range. Together these three items form a complete matrix describing a probabilistic estimate. Now see absolute relative estimating. Absolute estimates are specific information and use actual numbers. An absolute estimate for effort might be shown as 120 hours of work. One person working full time and could accomplish the work in 15 work days, assuming 8 hours of productivity per workday. While absolute estimates are specific, relative estimates are shown in comparison to other estimates. Relative estimates only have meaning within a given context. One form of relative estimating is planning poker. In planning poker, the project team performing the work comes to a consensus on the effort that is necessary to deliver value. Using story points to estimate work could result in 64 story points being assigned for that work. New work is estimated using the amount of estimated work compared to the points assigned to the previous work. Therefore, new work effort is compared to the previous known work effort. Now see flow-based estimating. Flow-based estimates are developed by determining the cycle time and throughput. Cycle time is the total elapsed time it takes one unit to get through a process. Throughput is the number of items that can complete a process in a given amount of time. These two numbers can provide an estimate to complete a specified quantity of work. Now see adjusting estimates for uncertainty. Estimates are inherently uncertain. Uncertainty by definition is associated with risk. Key deliverables, dates or budget estimate may be adjusted, or contingency, time or funds may be added based on the outcomes of situation conducted to establish the range of uncertainty for these parameters. Now let's see schedules. A schedule is a model for executing the project's activities, including durations, dependencies, and other planning information. Schedule planning can use predicative or adaptive approaches. Predicative approaches follow the stepwise process as follows. Step 1. Decompose the project scope into specific activities. Step 2. Sequence related activities. Step 3. Estimate the effort, duration, people, and physical resources required to complete the activities. Step 4. Allocate people and resources to the activities based on availability. Step 5. Adjust the sequence, estimates, and resources until an agreed upon schedule is achieved. If the schedule model does not meet the initial desired end date, schedule compression methods are applied. Crashing is a schedule compression method that seeks to shorten the duration for the least incremental cost. Crashing can include adding people to activities, working overtime, or paying to expedite deliverables. Fast tracking is a schedule compression method in which activities or tasks that are normally done in sequence are performed in parallel, at least for a portion of their duration. Fast tracking often entails applying leads and lags along a network path. A lead is where the work of successor activity is accelerated, such as starting a successor activity before the predecessor has finished. In figure 2.16, there is a lead between finish of task 2 and the start of task 4. Okay. This is figure 2.16. A lag is a delay of successor activity. An example of using a lag would be changing the type of relationship between activities and then applying a lag. For example, rather than waiting for an activity to finish before the next one starts, a finish to start relationship, change the relations to have the end of the successor activity finish a determined amount of time after the end of the predecessor finish to finish relationship. The network logic would show a lag between the finish of the predecessor and the finish of the successor activities. There is an example of finish to finish relationship with a lag in figure 2.16 between task 8 and task 7. Let's see task 8 and task 7. Okay, you can see this two tasks 7 and 8. A lag can also be applied between the start of one activity and the start of another activity, start to start relationship. When compressing the schedule, it is important to determine the nature of the dependencies between activities. Some activities cannot be fast-tracked due to the nature of the work. Others can. The four types of dependencies are mandatory dependencies, discretionary dependencies, external dependencies, and internal dependencies. Let's see what is mandatory dependency. A relationship that is contractually required or inherent in nature of the work. This type of dependency usually cannot be modified. Discretionary dependencies. A relationship that is based on best practices or project preferences. This type of dependency may be modifiable. External dependency. A relationship between project activities and non-project activities. This type of dependency usually cannot be modified. And internal dependency. A relationship between one or more project activities. This type of dependency may be modifiable. Adaptive scheduling planning uses incremental planning. One such scheduling approach is based on iteration and release. See figure 2.17. A high-level release plan is developed that indicates the basic features and functionality to be included in each release. Within each release, there will be two or more iterations. Each iteration adds business and/or stakeholder value. Value may include features, risk reduction, experimentation, or other ways of delivering or protecting value. The planning for the work in feature release is kept at a high level so the project team does not engage in planning that could change based on feedback from earlier release. Figure 2-17 reads an iteration plan. Product vision drives product roadmap. Product roadmap drives release plan. This is release plan, iteration 0, 1, 2, 3, and 4. Release plan establishes the iteration. This is iteration plan, features A. user story 1, feature A, user story 2, and so on. Iteration plans schedule features development, prioritize features delivered by user stories estimated in story points, task estimate in hours created to deliver user stories. Adaptive approaches often use time boxes. The work in each time box is based on a prioritized backlog. The project team determines the amount of work they can do in each time box, estimates the work, and self-manages to accomplish the work. At the end of the time box, the project team demonstrates the work completed. At that point, the backlog estimate of work available to be done by updated or prioritized for the next time box. Determining the schedule involves using the information in estimating section to determine overall duration and effort estimates. Regardless of the scheduling approach used, the relationship between effort and duration needs to be addressed. Some activities are effort driven, which means that the duration can be reduced by adding people. This approach can work up to point after which adding people might actually extend duration. Framing a building is effort driven. If more people are added, the duration can be reduced. Some activities are fixed duration, such as running a test for conducting employee training. The nature of work determines if and how much the duration can be reduced. By adding people before increasing the time due to coordination, communication, conflict, and potential rework, there is no fixed formula to determine the reduction in duration due to the addition of people. Now the budget. The project budget evolves from the agreed estimates for the project. The information in section on estimating is applied to project cost to develop cost estimates. Cost estimates are then aggregated to develop the cost baseline. The cost baseline is often allocated across the project schedule to reflect when the cost will be incurred. This practice allows project managers to balance the funds approved in a specific budget period with the scheduled work. If there are funding limitations for budget period, the work may need to be rescheduled to meet those limitations. The project budget should include contingency reserve funds to allow for uncertainty. Contingency reserves are set aside to implement a risk responses or to respond to risk events should they occur. Management reserves are set aside for unexpected activities related to in-scope work. Depending on the organization policies and organizational structure, management reserve may be managed by the project, the sponsor, product owner, or the PMO at the program and portfolio level. Figure 2-18 shows the budget build-up. Now we will go to the next topic, that is project team composition and structure. Planning for project team composition begins with identifying the skill sets required to accomplish the project work. This entails evaluating not only the skills but also the level of proficiency and years of experience in similar projects. There are different cost structures associated with using internal project team members versus securing them from outside the organization. The benefit that outside skills bring to the project are weighed against the costs that will be incurred. When planning for project team, the project manager considers the ability and necessity for the project teams to work in the same location. Small project teams that can work in same room are able to take advantage of osmotic communication and can solve problems as they arise. Some project teams are physically dispersed. Project team members may be in different cities, time zones, or countries. On projects where project team members work virtually, more time is spent connecting people through technology. Now see communication. Communication planning overlaps with the stakeholder identifications, analysis, prioritizations, and engagement as described in the stakeholder performance domain. Communication is the most important factor in engaging with the stakeholders effectively. Planning communication for project entails consider the following. Who needs information? What information does each stakeholder need? Why should information be shared with the stakeholders? What is the best way to provide information? When and how often is information needed? And who has the information needed? There may be different categories of information such as internal and external, sensitive and public, or general and detailed. Analyzing the stakeholders' information needs and categories of information provides the foundation for establishing the communication processes and plan for the project. Physical resources. Physical resources apply to any resource that is not a person. It can include materials, equipment, software, testing environments, licenses, and so forth. Planning for physical resources entails estimating, as described earlier, as well as supply chain, logistics, and management. Projects with significant physical resources, such as engineering and construction projects, will need to plan for procurement activities to acquire the resources. This may be as simple as utilizing a basic ordering agreement or as complicated as managing, coordinating, and integrating several large procurement activities. Planning for physical resources include taking into account lead time for delivery, movement, storage, and disposition of materials, as well as means to track materials inventory from arrival on site to delivery of an integrated product. Project teams whose projects require significant physical materials think and plan strategically about the timing from order to delivery to uses. This can include evaluation of bulk ordering versus cost of storage, global logistics, sustainability, and integrating management of physical assets with the rest of the project. Procurement. Procurements can happen at any time during a project. However, upfront planning helps to set expectations that ensure the procurement process is performed smoothly. Once the high-level scope is known, project teams conduct a make or buy analysis. This includes identifying those deliverables and services that will be developed in-house and those that will be purchased from external sources. This information impacts the project team and the schedule. Contracting professionals need advance information on type of goods needed, when they will be needed, and any technical specification required for the procured goods or services. Now the changes. There will be changes throughout the project. Some changes are result of risk event occurring or project environment change. Some are based on developing a deeper understanding of requirements, and others due to customer requests or other reason. Therefore, project teams should prepare processes for adapting plans throughout the project. This may take the form of change control process, reprioritizing the backlog, or rebaselining the project. Projects that have a contractual element may need to follow a defined process for contract changes. Matrix. There is a natural linkage between planning, delivering, and measuring work. That linkage is matrix. Establishing matrix include setting the threshold that indicate whether work performance is as expected, trending positively or negatively away from expected performance, or unacceptable. Deciding what to measure and how often is best informed by the phrase only measure what matters. Metrics associated with the product are specific to deliverables being developed. Metrics associated with the schedule and budget performance are often driven by organizational standards and are related to a baseline or an approved version of the schedule or budget against which actual results are compared. As a part of planning, the matrix baseline and threshold for performance are established, as well as any test and evaluation processes and procedures that will be used to measure performance to the specification of the project deliverables. The matrix baselines and tests are used to the basis to evaluate variance of actual performance as part of measurement performance domain. Now we'll go to next topic, that is alignment. Planning activities and artifacts need to remain integrated throughout the project. This means that planning for performance in terms of scope and quality requirements align with delivery commitment, allocated funds, types, and availability of resources. The uncertainty inherent in project and stakeholder needs. Project teams can require additional planning artifacts depending on the type of project. For example, logistic plans will need to integrate with material and delivery needs. Testing plan will need to align with quality and delivery needs, and so forth. Work on one project often occurs in parallel with other projects in a program or release. The timing of work of single project should align with needs of the work on related projects and the operation work for the organization. Large projects may combine the planning artifacts into an integrated project management plan. For smaller projects, a detailed project management plan will be inefficient. Regardless of the timing, frequency, and degree of planning, the various aspects of the project need to remain aligned and integrated. Now I'll see interaction with other performance domains. Planning occurs throughout the project and integrates with each performance domain. At the start of the project, the expected outcomes are identified and high-level plans to achieve them are developed. Depending on the selected development approach and life cycle, intensive planning may be conducted upfront, and then plans may be adjusted to reflect the actual environment. Other life cycles encourage just enough planning at various points throughout the project with the expectation that plan will evolve. Throughout the project, planning guides the project work. Delivery of outcomes and business value. Project teams and stakeholders establish measures of progress and success, and performance is compared to plans. Uncertainty and planning interact as project teams plan for how to address uncertainty and risks. Plans may need to be revised or new plans developed to account for events or conditions that emerge. The project team members, environment, and project details influence plans for working effectively with the project team and engaging proactively with stakeholders. checking results. Table 2-6 checking outcome, planning performance domain. Table 2-6 identifies the outcome on the left and ways of checking them on the right. Table 2-6 checking outcomes, planning performance domain, outcome check. The project progress in an organized, coordinated and deliberate manner. There is a holistic approach to delivering the project outcomes involving information. So let's see outcome and check. Outcome: the project progress in an organized, coordinated and deliberate manner. There is a holistic approach to delivering the project outcomes. Check. A performance review of project results against the project baseline and other measurement metrics demonstrate that the project is progressing as planned. Performance variance are within threshold. The delivery schedule, funding, resource availability, procurement, etc. demonstrate that the project is planned in holistic manner with no gaps or areas of misalignment. Outcome: evolving information is elaborated to produce the deliverables and outcomes for which the project was undertaken. What to check? Initial information about deliverables and requirements compared to current information demonstrate appropriate elaboration. Current information compared to the business case indicates the project will produce the deliverables and outcomes it was undertaken to deliver. Outcome: time spent planning is appropriate for the situation. What to check? Project plans and documents demonstrate that the level of planning is appropriate for the project. Outcome: planning information is sufficient to manage stakeholder expectation. What need to be checked? The communication management plan and stakeholder information indicate that the communication are sufficient to manage stakeholder expectation. And outcome: there is a process for adoption of plans throughout the project based on emerging and changing needs of or condition. What to check? Projects using backlog show the adoption of plans throughout the project. Projects using change control process have change logs and documentation for change control board meetings that demonstrate change control process is being applied. Okay, that brings us to end of my presentation. Thanks for watching. In next video we are going to explore project work performance domain. I hope you would have found this information useful. If you like my videos, please subscribe to my channel.